Alright guys, here are your notes. This is going to be your notes 3b.2. Sorry about that. We're going to talk about congruent corresponding parts and congruent parts of figures, polygons, mostly focusing around triangles because that is what Unit 3 is about. Okay, so the first thing we're going to talk about is finding corresponding parts. So this section right here, I will be using several different colors, okay, to help out here. When we take a look at the first over here on the left-hand side, corresponding objects are those that appear in the same place in two similar figures. Here we're being told that triangle ABC is congruent to triangle DEF. Now that we're starting to talk about corresponding triangles, the order of the letters will matter. Okay, and that's what this is what we're going to be talking about here. The first thing we're going to go ahead and do is start identifying our corresponding angles. I know it says corresponding sides first, but I'm going to go over here and go to corresponding angles. And what we're going to do is talk about the three different letters in the triangle are your three different vertices, which are your three different angles. So what happens is this first angle, the first letter that's written here, angle A, is going to correspond with the first letter in the second triangle. So it will correspond with angle D. So here we can say that angle A is congruent to angle D. Okay, I know it says corresponding parts, but we're just going to go ahead and start talking about them being congruent as well, if the two figures are congruent. The next one that we have here, the second letter in the first triangle is B, so it's going to correspond with the second letter in the second name. So angle B will correspond with angle E, and when the triangles are congruent, angle B will be congruent to angle E. Lastly, we have C will correspond with F. So angle C over here will correspond with angle F, and in congruent triangles, we will say angle C is congruent to angle F. So the order matters again with the sides as well, but now we're going to be taking a look at multiple letters, because we need to remember your sides are segments. They consist of two different endpoints, so two different letters. So you take a look at the first triangle, the first two letters here, AB, so this side right here, will correspond with the first two letters in the second one, giving us segment AB in congruent triangles. Segment AB will be congruent with segment DE. Go ahead and highlight that over here as well. Next, we will take a look at the last two letters. Here we have BC. BC right here will correspond with the last two letters in the second one of EF. So when the two triangles are congruent, we could say that segment BC is congruent to segment EF. Lastly, we have the outer two letters, the first and the last letters. So A and C will correspond with the outer two letters of the second one, D and F. And in congruent triangles, that will give us segment AC will be congruent to segment DF. Okay? I'm going to draw a little line here to separate those two. So when we look at the example we have over here, we're told that triangle ABC is going to be congruent to triangle DEF. So what I'm going to start off with is my sides here. I'm going to go ahead and just kind of go ahead and label everything here. AB. So if I find AB right here, it is going to correspond with DE right here. So those two will be congruent. The last two letters, BC, will correspond with EF. So I find BC right here will correspond with EF right here, making these two congruent. Then lastly, we have our outer two letters, AC, are going to correspond with DF. So AC will correspond with DF, and they will be congruent. With our angles, the first letter A goes with the first letter D. So angle A and angle D will correspond. B will correspond with E. So angle B and angle E will be corresponding. And the last letter C will correspond with F. So C will correspond with angle F. Now that I have everything there, even though we're not going to need all of it, I want to make sure that we have that and we're looking at it again like we did on the other part. We're going to go ahead and answer the following questions. A is talking about segments BC. So if we look over here, we find segment BC right here. Segment BC is going to be congruent to segment EF. That's why I have them color coordinated. Again, you could just look in the name as well. BC and EF. Angle F here, okay, is going to correspond, it's the last letter, it's going to correspond with C. So angle F and C, angle F will be congruent to angle C. C is asking for angle A. Angle A and angle D correspond. Therefore, in congruent triangles, angle A is going to be congruent to angle D. The next one is changing up a little bit. We're looking at measurements. So in reality, this should not be here because we don't have measurements congruent. Measurements are equal, so we'll go ahead and cross that off. The measurement of angle E. So if we look at angle E right here, we don't have a measurement there. We don't have a measurement on any of these, so we can't even use triangle sum theorem. What we do, though, in this situation is we find the angle that corresponds with it, angle B. As you can see, it's the middle letter. These two correspond, and there's our measurement. Since they are congruent, their measurements will be equal. Definition of congruent angles. So this will equal 77 degrees. The next one is talking about the length. There's no line above it, so we're not talking about segment DF. We're talking about the numeric value, the actual measurement of DF over here. Again, we don't have a measurement, but we do have a congruent triangle over here that we have a measurement on. So AC and DF are going to correspond. So giving us the measurement of DF is going to be 5 centimeters as well. F is going to explain exactly, or it's going to show, how exactly that the order of the letters do matter. We're still using the same letters as this one, we're just rearranging them. If we rearrange these letters, we have to rearrange the other one correctly. So if we look, they used letter A first, so A corresponded with D, so we can still say it's congruent to triangle D. The second letter they used was C, so we have to go up here and see, okay, which one corresponded with C? It was F. So we have to put F next. Leaving the last one, B. B corresponded with E. So now it really matters what order we put these in. Okay? So let's look at some congruent figures here. I think there's something on here we're going to have to change to. Figures are congruent, and this should say if they have exactly the same size and same shape. That is a definition of congruent figures. Same size, same shape. Therefore, their corresponding sides and their corresponding angles must be true, or must be congruent as well, and that's what we just looked at. So here, we're not going to be looking at triangles, but it doesn't matter what figures, what shape they are, what kind of polygon. Here we have some trapezoids. We still have things that are going to correspond. The order of the letters is still going to correspond. The first, A, will correspond with E, B corresponds with F, C corresponds with G, and D corresponds with H. So we need to find X and we need to find Y. So I'm going to do these in two different colors so that we can see the difference between them. X, we see, is going to be in this angle right here. Okay? So we're looking at angle F. We have to figure out which angle corresponds with angle F. We look up here, F is the second letter in the name, so F will correspond with the second letter here, B. So now we have something to set that equal to. So we can say 7x minus 9 is equal to 110. And we could go through and solve for x. Adding 9 to both sides, we're left with 7x is equal to 119. Divide both sides by that 7. X will come out to 17. Okay? Next, with the blue, we're looking at solving for y. Y is over here at this segment right here, FG. And if we look over here, FG are going to be the middle two letters. So they're going to correspond with the middle two letters right here, BC. So if we look up here, we have BC right here. So now we can set 3y minus 12 equal to, so mark them congruent, equal to 6. Solving for x, add 12 to both sides. We have 3y equals 18. Divide both sides by 3. Y will equal 6. Okay? Please make sure that you rewind if you need, if it went too fast, rewind and listen to it again if you need to. The third angles theorem is a pretty simple theorem here. It states that if two angles of one triangle are congruent to two angles of another triangle, that third angle on each one is automatically congruent. This is based upon your triangle sum theorem. If you add them together and subtract from 180, which is what we're going to do over here to prove the third angle theorem. On this one, it is telling us that angle 1 is congruent to angle 4. So 1 and 4 are congruent. They also tell us that angle 2 is congruent to angle 5. So what ends up happening automatically is the third angle, for the third angles theorem, angle 3 will automatically be congruent to angle 6. Okay? We're going to test that theorem over here, and we're going to see, now they don't tell us the names of the triangles, but they do have measurements. So on here we can see angle A, 35 degrees, should correspond with angle H, because that is also 35 degrees. Angle B is marked as 88 degrees, so it will correspond with the other 88 degrees of angle I. And then C, the missing one, will correspond with J. So what we will do first is we will take a look at triangle ABC, and we will use the triangle sum theorem to figure out what that third angle, angle C, is. So here we will take 88 plus the 35, the two angles that we have. We add those together, we get 123. We subtract that from 180, triangle sum theorem, and we get 57 degrees. So we can say that angle C over here is 57 degrees. In order for the triangle, the third angles theorem to be true, the same thing will happen over here. So if we take triangle HIJ, we take that 88 plus the 35. We add those together to get 123. Subtract that 123 from 180, and we get 57 degrees again. So this right here has proven the third angles theorem by using your triangle sum theorem. Okay? That is the end of your notes 3b.2.